Hello, welcome to Building Energy. I'm your host, Jared Downey. Today on the show, we have our third episode of ABB. We've had some great discussions with people from their team already, and this one is no exception. We've got Jay Misheal. He is the Business Development Manager, Utility Segment, ABB Canada. And we've got Dominique Tardif. He is the Product Marketing Manager, Medium Voltage and Utility, Electrification Installation Products at ABB Canada. And the topic today is underground cabling. As you know, in Canada, we've had fires, we've had floods. The discussion is in huge demand, the product is in huge demand, and we've got two fantastic experts to unpack it for us. So without further ado, enjoy the episode. Gentlemen, welcome to the show. Great to have you on.
Thank you very much. I'm glad to be here.
Maybe, Jay, start with you, then Dominic, over to you. Just your roles with ABB.
Yes, I am the National Business Development Manager for medium voltage products in the utility segment in Canada. So I work with utilities from the eastern region all the way to the west coast.
And Dominic?
Very good, and similar to Jay, as opposed to being the commercial interaction with the client, I'm basically the one that has the product line responsibility across the same territory from production facilities out of throughout North America, mostly out of the U.S. and a little bit here in Canada. That covers what we refer to as the medium voltage product line, so the apparatus, the cable accessories, and distribution connectors for all of Canada.
And today we're really focusing on the underground cabling solutions. So Jay, and I know both of you will be jumping in here. I've had meetings with you before, and there's plenty of back and forth. So, but Jay, we'll just start with you to tee it up. I wanted to, before we jump into what is being done now and all the how much better it is, I wanted to give the audience an understanding of how everything was done before underground cabling became sort of the demand.
Yeah, certainly. I mean, in Canada, our electrical infrastructure for decades had been the same, where you would have large generating stations that would generate electricity. And from there, it would go across thousands and thousands of kilometers of transmission lines. And from there, it would go to distribution lines, and then, of course, to homes and businesses. So today, it's a little bit different because you have a lot of distributed energy resources, DERs, like solar sites, for example, or wind farms or battery energy storage systems that need to be integrated into the grid. You also have microgrids potentially going up in remote areas where they're like their own little system where they generate, transmit, and distribute electricity. So in the past, that's how we've always done it. We big generating stations transmit the electricity and then take it from there to homes and businesses. But slowly, that's changing. By the vast majority of cabling would have been overhead on either hydro poles or large transmission poles that would take the cabling across the country. It's estimated that there's over 160,000 kilometers of cables on overhead lines from Canada, and some even stretch down into the U.S. as well.
Yeah, well, it's exactly like Jay said. Basically, it's like you got to keep in mind that electricity is a relatively new innovation for the human race. We'll say it's not something that showed up 10,000 years ago. It's only about 100 years old. We'll say maybe a bit older than that, depending where you're at. And basically, the requirement for electricity or for energy to be used, in a household or locally was kind of an organic growth system, right? There was a power generation station of some sort. Like Jay said, there was transmission lines, but then how it went to where it needed to be was kind of a setup which was done on hydro poles, and it would kind of take the direction that the population was able to pay for it or able to require this electricity. So it was very organic. And so, of course, you can imagine how crowded these hydro poles would have got, because if there wasn't any strategic planning behind where the electricity needed to be 20, 30, 40 years down the road, it was a very emerging technology. And then all of a sudden, it became a household system that people were used to having. You'd flip a switch, the lights would come on, and you'd use it all the time. And this is where I think utilities had to become a little sharper, had to start doing a little more planning, and I started having to be more strategic about how you start supplying your grid because more and more people had this necessity as opposed to just a luxury of what it would have been maybe 50, 60 years ago, a luxury, and now it's become an absolute necessity.
Well, we're talking about like fires and floods. The thing that come to my mind when you're saying this is some of that infrastructure. I mean, some of that's getting now quite aged out, I would think, right?
Oh,
Yeah, a
sure,
lot of
Jay. Go ahead.
Canada's infrastructure is aging, and that's one of the challenges that the utility companies face today, right? Aging infrastructure. It's estimated, $350 billion is going to be spent between now and 2030 before we can bring the grid up to where it needs to be. While doing this, they're tasked with keeping the lights on. So you mentioned fires and floods, hurricanes. We've seen some hurricanes out east, for example, that did significant damage to hydro poles. So, they're faced with that as well. And safety is another big concern when you have an ice storm or a windstorm that could take down hydro lines. Those hydro lines oftentimes will come to the ground live. Anyone in the area could potentially get electrocuted. So safety is another concern and challenge that they have, right? So grid reliability and resiliency, as well as efficiency, are some of the challenges that utilities are being faced with, on top of the fact that they're being tasked with reducing their carbon footprint. So you have legislation that's forcing them to either look at carbon capture systems or retiring coal plants altogether. Now, we don't have that many of them anymore in Canada, but they still do exist. So for some utilities, that poses a challenge there as well. As well as, urbanization. You have people flocking to urban areas,
Mm.
increasing the demand. For example, where you had a transformer feeding potentially 2,000 homes, and that all of a sudden that population had doubled, right? So that transformer no longer can sustain that kind of a load, so it needs to be upgraded, modernized, right? Along with that, equipment feeding it and on the load side of it have to be upgraded. Lines potentially could have to be upgraded. So there are several challenges that the utilities face.
It's absolutely right. If we were to put it into context, you got to imagine that it's very difficult to anticipate what's going to be happening 20 years down the road. Like Jay says, especially in an urban area, there was let's say about 60 years ago when you had an 8-story building, that was kind of the limit you would see, and it would be kind of standard for a commercial building. But now, in that same area, the population density has doubled, even tripled, and basically the energy demand has, it's despite going down ever so slightly per individual, the demand in that square foot of building or that square foot for that plaza area has skyrocketed. So there's no engineer on earth that's able to anticipate 20 years down the road a threefold growth when he's sizing up a grid network like a transformer of some sort. They oversize it to be about 80%, or operating about 80% of its capacity, maybe
Right.
75%. And here we are, we've doubled the population in a 30-year span, and you're not going to have me believe that the transformer and all the critical components attached to it are not maxed out and haven't been kind of pushed to their limits, especially in a very cold winter in Canada. We do operate on electricity quite a bit to keep the pipes from freezing.
Right. You mentioned organically, and something that's coming to my mind is when you're, and we'll talk about this transition to more and more underground, but are they still having to organic so are they keeping the above ground and piecing it? I'm not an electrician or an engineer, and everybody will figure that out really
And
quick with this question. But I'm wondering, are they still piecemealing it together organically, or is there a bigger focus on, okay, this is going to keep happening. We need to now put together a plan. I'm sure it varies by city to
yes,
city. And
it's an excellent question, and it's a little bit of both, right? Because your plan's only as good as what you know, right? So they do have plans put together. There is organic growth that happens because there's always a percentage of things that kind of set out a certain way, and they're structured that way. We'll say in the urban areas, not urban, in the rural areas, you kind of send out your lines and this, and suburbs come up and they get requests to have it set up. And when they're asking for permits, it's not just the permits to be able to build and zoning in the land, it's permits so that the utilities are able to start planning and get the requests for what they need for new buildings, new homes, new structures, new industries, and so on and so forth, so that they could upgrade their capacities, as you can imagine. But there's always basically, even though the utility is not going to turn down new business, at the end of the day, they're basically trying. They're in the business of selling us electricity, so they're going to try to supply it as best as they can, right? So if we're sitting there and we have a project that requires more installations, more houses, more commercial buildings, and we could plan ahead, it starts to make things a little more structured because they're not wanting to have a repeat of what's happened in the past where things would just kind of show up and then you're trying to put on a bunch of power poles and a bunch of power lines left and right. I think there's a lot more planning going into it now because they don't want to have to relive that. And the thing is, the investment of going underground to keep it visually nicer is a little higher. It costs quite a bit more money to go put something underground and you have to plan for it. And the thing is, when you're going underground, there's other things underground along with your electricity. You've got sewers, you've got the aqueducts, so the water inlets are coming in too. You've got other service factors that are to be considered. Foundations, there's all kinds of river structures we got to keep in mind, and especially in older cities, there's all kinds of stuff under there that you don't even know is in existence. So you have to have quite a bit of
Yeah.
planning tied into your organic growth.
Yeah, absolutely. As Dom mentioned, planning makes it easier. If you have a new subdivision, for example, new construction, you can plan to put those cables underground, which definitely help mitigate issues when it comes to, of course, forest fires, floods, car accidents, taking out hydro poles, things like that. As well, don't forget that it is a little bit more aesthetically pleasing, right? So if you have a new subdivision, you don't have overhanging lines, so
Mhm.
children flying kites in parks and so on don't have to worry about hitting overhead lines, right? But you do have a challenge when the infrastructure is already there. If you could picture, for example, a downtown core of Toronto or Montreal or any
Mhm.
major city, real estate is at a premium. And to move those lines from overhead to underground is not as easy because I don't think it was planned at the time that those were built. So those pose some challenges. However, some major cities are absolutely considering it. Some are acting. Some are converting some of their overhead lines to underground, even though it is costly, especially in the coasts where they could face heavy windstorms and fires and so on. It does pay off, I think, to convert. So that is happening.
Is that
But
and how just kind of going, just kind of zeroing in on that then, Jay, if they're doing that, is that again, not being an electrician or an engineer, I would assume that you could do it sort of block by block. Like I saw that when they put in all those Ethernet systems, they were doing it sort of street by street. Can you do that the same way, or is electricity a bit of a different plan to, I mean,
no,
I've been to cities around the world where it's
yes,
all
yes.
above ground and it's just wild. I mean, you just it's quite the
Yeah,
thing.
no, that's a good question. They can do it in phases. I don't think they do it all one shot. It's almost impossible to do it all one shot. So it is done in phases. The network is well monitored, I think, now, and the utilities are well aware of where they can cut power, divert power from different sections, and do sections at a time. So that is what they will do, and that there's a lot of planning, a lot of effort involved in that. You simply can't just take overhead lines, start digging and putting underground lines. You have to get approvals from the municipalities. You have to work with them. You have to do environmental assessments. So they do face a lot of challenges while doing it, but nonetheless, it is being done.
And how is that combination, Dominic, to go over? We've already sort of touched on it, but I kind of want to walk through it. When you're looking through the values of going, because it is such a major investment. If you're down, a downtown Toronto, not downtown, but some area in Toronto where it's overhead,
Suburban.
or Montreal, or anywhere, even some of these older small towns that are now starting to see more infrastructure go into
Yeah,
place. Um,
absolutely.
what's the discussion to say, okay,
Well,
this is worth the investment?
yeah, well, the discussions usually, it's like Jay said, it's usually, it's always easier on a black and white principle. When you have a brand new subdivision going up, well, you've decided you're making the investment for our brand new subdivision to be with underground cabling. We'll say we'll go underground with it, and that's a decision that's made by whether it be the municipalities or the urban planners or the local councils will decide that's the way they want to make it look and make it modern. um, to start making the decisions, like Jay said, to go from overhead to underground and completely bury something that's already in existence, I think the return on investment could become a little difficult. That's something to be aware of. I think they'll get to it when they get to it, because you got to keep in mind populations do move around, and neighborhoods change up. We've how many downtown cores have you been to that used to have textile mills and they've turned into condo buildings over the past 50 years, right? So when you start doing a major renovation, that's a good time to make that step, because usually it's going to be worthwhile at that time. But we do have some, there's a few transitional technologies that are out there too right now. Because I don't think, we're never going to be in all of one or all of the other. There's going to be a transition period that's going to happen, and I'm convinced, Jay and I will have the same conversation 100 years from now, although we'll be a little long in the tooth by then. And I'm sure there will still be some above ground setups still operating, and it's still the convenient way to get electricity somewhere. And so there are kind of transitional technology. Something like what we call the storm safe is a unit that basically is using the overhead lines, but making them more intrinsically safe and a little more reliable. That if a line does go down, it's kept safe. There's no electricity in it when the line's down, and you're able to get it reinstalled relatively quickly by a service team. So, for those lines that need to stay up, we do have technologies for that. Once we go underground, well, there's a whole product breadth that's made just for that, for whether it be direct burial, it could be the anything that's uh, dielectric, basically, that you could come into contact with, and in all cases, all our technologies, especially in the elastomeric product lines, are completely submersible, right? So you got to keep in mind that all these floods, all these snow melts, any kind of severe weather, most everything that we're offering that's underground is very reliable. It's very solid. It's waterproof. It's made to be able to operate in very severe conditions with extremely low maintenance, and that's something that we're very proud of.
There will be times where I have actually witnessed this, where customers will invest in moving from overhead to underground. I can give you an example of what I had witnessed. There was a very busy mall that had a transformer in the middle of the parking lot, and apparently parking is it costs a premium nowadays. So the customer wanted this substation, if you will, out of the parking lot. So he worked closely with the utility to build an electrical room, an addition to the mall, and they moved that equipment from the parking lot to
Mhm.
that electrical room. Went from overhead to underground because the lines were overhead on the road, and so they took a feed from there, went underground underneath the parking lot into the electrical room, and fed the rest of the mall from there. So yes, customer investment also can help support that transition from overhead to underground. So there are several reasons. We talked about aesthetics, right? That is one reason. Safety is another one. When you have storms, you don't want anything live on the ground, which potentially could cause some issues, of course. And as well as grid resiliency. I mean, this is a big one, right? Utilities can't afford downtime today. Some of them are measured on uptime, right? And whether or not they can provide price increases is based on that.
Mm.
So grid resiliency is a big one, and if they can avoid those events, for them, it's definitely beneficial. So they do see an ROI there as well. Now you have other things that come into play. I've seen videos, I'm sure many people have, of a bear climbing a line or an animal of some sort jumping across lines and shorting out lines. Um, things like that, or vermin getting into switchgear that's on the ground or on hydro poles that could cause some downtime as well, right? So those are some key things that make a difference. Also, I think this generation today is really cautious about the environment. So, sustainable, environmental, social governance is another one that plays into decisions that utilities are making today.
Mm.
They try to modernize the grid by removing things like oil-filled transformers with PCBs, switchgear, for example, that has SF6 as an insulation median.
Jay, sorry, could you just clarify what is SF6?
Yes, so SF6 is a greenhouse gas. It's used in switchgear to switch higher voltages, right? It's an insulation median that's used to switch anything above the 15,000 volts. It is a greenhouse gas that does destroy the ozone layer, and it sticks around for a couple thousand years, unfortunately. So you can move away from that to our solid dielectric switchgear. Dominic, I'm sure you can add to that.
Well, Jay, that's exactly right. Basically, the SF6 gas is an inert gas that's used to keep the size of switchgear minimized because you have to be able to extinguish an arc inside of these systems. And it's a well-known greenhouse or it's a greenhouse gas, an ozone depleting gas that's out there. And secondly, is once this gas has been through an electrical arc, which is not uncommon, it's in an electrical system. It's also a known cancer causing agent. So, like Jay says, these gases, uh, were a necessity at the time, and that's how it was a solution that was brought up years ago, and seemed to be a very good one. But of course, it's like everything else. Once we started looking into it and started doing some proper analysis, we've discovered that agent that we're using to extinguish the arc is probably not the safest one out there today.
So what's the alternative now to that?
Well, there's always been I think the basic way we could break it down is that there's probably the best insulator overall is just air. Dry air in itself is a good insulator, right? The problem is that you need a lot of dry air between the 2 points of electricity from the potential to the ground basically, or to the circuit it's trying to feed. So unfortunately, when you're using just dry air, you have a relatively large piece of equipment to be able to have that insulating gap, that air gap between point A and point B. The SF6 gas or some of these other inert gases that are on the market right now are able to reduce the distance between these two setups. So basically, the equipment starts to get smaller. And then the lack thereof, which is a vacuum bottle that goes inside of a piece of equipment, is the smallest thing you get. And we usually basically coat the outside of these things with basically EPDM rubber. So it's the rubber that's very similar to your car tires. It's just not vulcanized in this case. And that ends up making something that's very compact. So what would have been essentially 11 feet away, it comes down to about 6 feet away when you're down to the SF6 gas. And then you come down to just very few inches away when you get down to a dielectric solution like rubber.
Yes, Dominic's right. You at 27 kV or close to that, you need 11 inches gap to break an arc in air insulated switchgear. Now, this poses a problem because if you can imagine, in downtown cores, for example, such as Toronto or Montreal, other locations as well, space is you have constraints, space constraints. So you have underground vaults that are only a certain size where you have SF6 equipment in there, and you want to remove that antiquated SF6. You don't have the luxury of putting air insulated switchgear in there simply because you don't have the room.
You just have space. Yeah.
So the space. That's correct. In those confined spaces. So you would have to replace that either with another SF6 switch of similar size or something comparable size-wise. So that's where our elastomold solid dielectric switchgear comes into play for several reasons. It's very scalable. You can literally carry a switch. It's not required that you would have to remove ceilings or break walls to get the equipment in. And it's completely dead front construction. So you have a vacuum bottle, which is breaking the arc as the switch opens and closes, completely encapsulated in EPDM rubber. So you have no live exposed parts as you would with air insulated switchgear, right? And you don't also have, the concern in a confined space of working with SF6 gear because unfortunately, ABB manufactures SF6 gear. Many companies do. It's a necessity, unfortunately. However, in a confined space, SF6 always leaks. Over time, it's guaranteed to leak. You just cannot keep that darn gas contained in that switchgear. It will leak at some point. And if you are in front of that equipment, you're exposed to that. It could cause eye irritation, nausea, all kinds of different things, let alone harming the ozone layer. So you try to do away with it as much as you can. But I know some utilities are looking to ban SF6 from their system in the coming years. So this poses a challenge for them. What do you replace it with when you are in confined spaces?
That's a great. Oh, sorry, Jay. Yeah, that's a great point. I think, Jay, for our listeners too, it's that we probably should put a little bit of context into this too, because I don't think everybody can appreciate the distribution levels of electricity that we're having to deal with. Because people are saying, they're probably listening to this going, "Well, it's electricity. You just start driving it through special bus bars and all this." We're in a world for the medium voltage, or at least the distribution lines. It's what's called 15 kV, 25 kV, and roughly 35 kV voltage ranges. All right. So just let's just to put it into context, what the power coming into your house is basically two phases of 110 or 120 ish. So basically, it's 240 volts, right? That's what's feeding your house. But the equipment that Jay is talking about here, or at least the connectivity, the apparatus and the cable accessory components that we're talking about, are having to hold back 15,000 volts, 25,000 volts, and 35,000 volts, and not just for one wire. Most of this is operating on three phases of electricity, right? So you got phase A, B, and C driving it through. You're going through switches and so on and so forth. So you can imagine every time you have to keep this air gap or this separation or this capability to be far enough away that electricity doesn't want to go from one phase to the next, or wants to go from phase to the ground, because electricity is basically always trying to go from its high potential, trying to get to ground as quickly as possible. And us as human beings, we kind of force electricity to do things like go through motors, go through lights, go through whatever else first, and do what we need done with it, right? So I think that's super important when we're talking about this dead front EPDM rubber. That's where the human factor comes in, because when you go into something what's called a vault, vaults are usually small rooms, small cement rooms, if you will, not much bigger than, let's call it basically a standard bedroom, we'll say. And you've got 15 or 25 kV of electricity flowing through there through 3 or 4 different switches, all in very tight quarters. You could see where the potential for an accident can happen.
You're absolutely right. That is the case, right? We're switching much higher voltages. It's not your typical light switch at home, right? And the connection interfaces are different as well. Unlike your light switch at home, where you can feed your wire into your switch, tighten the screw, and you're good to go. Unfortunately, it doesn't work like that with medium voltage products. So you're talking about, big cables with rubber elbows potentially on them that plug onto a bushing. And you don't do that by hand. You use 10-foot, 12-foot hot sticks to be able to plug cables and remove cables because there's potential there for an arc that could be catastrophic for human beings, right? So
that's an excellent point, Jake, because I think just for the benefit of our listeners too, is that when we're if anybody's done a little bit of home wiring, or you see your computer cables go into your screens and all that, you see these things that are about the size of a pen, right? A pen or pencil, as far as the overall size, and it has the 3 wires inside. It has a black wire. It's got the return to neutral, and there's the safety ground on it. The cables that Jay's talking about here, typically some of the smallest ones we see are starting to be about the size of your thumb, for the conductor itself, and then you put the insulation on the outside, so it starts to be about the size of your wrist. And then some of our larger installations, these things are literally like tree trunks. They're about 4 inches across. There's a very small conductor inside, but there's a lot of insulation on the outside to keep this all in. So the terminations, or the units that we put onto these cables, have to be solid. They have to be robust. They have to be watertight, as you can imagine. And like Jay said, as opposed to using a little set screw to put the thing into the side of the light switch, well, we're bolting these things together, or they're connected together with special mechanisms to make sure that they stay in place and they're locked in and they stay waterproof on top of all this.
Sorry, that's very key. That's right, because a lot of this equipment has to be submersible.
Oh, yeah.
Sometimes it grows in underground. It goes in underground vaults
Yeah.
and downtown cores. Sometimes you'll be walking down the sidewalk and you'll see a steel grate, and you wonder what's down in that steel grate. Well, some of that equipment is down there, so they're exposed to melting snow, water, oil from vehicles, all kinds of.
That's a great point, right? Jay.
That sort of leads me to that what holds people back from making these investments, because when you're building that infrastructure out in these environments, how much of that is the discussion when you're essentially convincing people? And before I'd ask that, I wanted to clarify something. Is it cost prohibitive? Is it a much bigger budget commitment? I would assume it is, to put something above ground than below.
Yes, I can't. I don't think Jay and I would be able to, to give you a solid, difference in price range. Like, because there's a lot of factors that play into it, right? Because, for example, if if you've already got the capability to put your vault together, or you've got pre-made vaults made, or you've got, like Jay said, rooms kind of set up in an old parking lot, which used to be a commercial center. So out of a parking lot into like a mechanical room in a large commercial building, a lot of this plays into it. And honestly, there's so much expense that goes everywhere, is that quite often, as long as you're planning far enough ahead and you kind of know what you're doing, and you've ordered your stuff in, it is more money. But usually at the end of the day, it's hard to beat the aesthetics, and then after that, the reliability and the safety that goes into it. To relate another story is, my wife and I decided well, we decided, it was decided we were renovating for the third time in this house. And at the time,
I like how we're just going to let you breathe by.
Yes, because I get up in the morning deciding I want to renovate. Exactly. I think we're all in the same boat. And one of the key irritants was that long, long, long line that was coming from the road. I do live in the country, so it's a bit of a haul between the post or the pole that's over by the road, and there's one pole that was my own. It's, as a homeowner, you have your own poles too, and it comes into the house. And she was just, didn't like the aesthetics of it. It's that big wire, and it's one of those things, I think you don't really notice it. It's just there. And she would kept mentioning it. So yes, we do have a product in the ABB group that was allowing us to be able to bury basically the cable. It's a different application. It's not medium voltage in this case. It's just a service entrance basically for a house, and coming in underground. And I was to tell you, yes, it cost money. Yes, it was a fairly major investment. There's no line coming into the outside of the house anymore. It's all underground. And when you look at the newer residential constructions now, no one notices that there's a line above ground until you go back into an older area and you start seeing those lines all over again. You said, those things, they're a bit of an eyesore, but you don't notice that they're there until you've been to a place that doesn't have them.
Yeah, and to add to that, Dominic, actually, you brought up a very good point. If you look at overhead construction, overhead lines to residential homes, you'll notice that the lines may come from the hydro poles to a mast that's on the home.
Mm.
And should there be a windstorm of some sort, or a tree falls down on the line or something and rips that mast off the home, that unfortunately is at the homeowner's expense to
It's a
repair.
homeowner's problem. Yep.
It's a homeowner's problem. So the utility will fix the line up to the home, but the mast is on the home. Now, as you can imagine, if you're a homeowner and there's a storm and it rips the hydro line down and takes out your mast, you're not going to be too happy about replacing it, because it's not cheap to replace.
Mhm.
So there is that too, where in new construction, like in the home I live, it's all underground. It runs underneath the sidewalks to my house through the basement wall, and I have no fear of any trees taking out any hydro lines. So the ABB equipment that we offer does do that. It can switch those much higher voltages as well. We have the connections, the interfaces to allow the cable installations onto that equipment, completely submersible, water environment proof, and safe, right? Which is a key priority, I think, for many utilities, as it should be, because you never want to have accidents where employees can be electrocuted, or hurt in any way. So the ease of installation, the fact that it is safe with the dead front construction that we offer, the fact that it is environmentally friendly, and yes, Dom had mentioned total cost of ownership. It may be a little bit extra upfront to purchase the equipment, but once it's installed, you virtually never have to touch it again. I mean, there is
Aesthetics, peace of mind.
absolutely there's no maintenance to be done on that equipment. And there's a lot to be said for that, because if you have to send a bucket truck somewhere, or highly trained staff to do maintenance on equipment, that gets costly too, right? So you have to look at the years that equipment will be in service
And that's
and
a
the
good
total
point you
cost of
brought up
ownership,
about
right?
the mast, Jay. You know the mast, the service entrance, the mast that comes into the house, basically. It's not a do-it-yourself project either. If that breaks, you need a certified electrician to come in and do that repair. And Jared, I don't know if you've ever had this situation, but when a storm comes through, usually it doesn't hit one house. It's hit hundreds of houses, and you can imagine what it's like to try to get your certified master electrician in to get your mast replaced when
One,
the whole
yeah.
neighborhood needs a mast, right?
Yeah.
Two
Try
weeks.
it a
Yeah.
week or a month, even, as what we experienced in the East Coast, for example, with those disastrous storms that we had, right? Not enough staff could work overtime to bring the electricity back in a day or a week or even 2 weeks, right? So,
In the Black Triangle, Jay, during the ice storms in, was it 98, 97, 98? I think it was the spring of 98, if memory serves.
yes,
We were out of power
yes,
for like something like 6 weeks. It was, let's just say we were back to wood stoves and boiling water. Yeah.
yeah.
Yeah. The,
So it is compelling to move from overhead to underground for a lot of the utilities, and I'm sure that every one of them is considering it, planning it, looking at it, and where there's opportunity to do so, they're doing it.
I just wanted to clarify something just for like homeowners in particular that are hearing this. It just is if they're doing work in their on their property and they've got underground systems. How are you supposed to approach that? I would assume you reach out to the city, but if it's not the city, then is that an electrician that needs to find it? I'm just wondering if for whatever reason you need to dig a hole, you're going to dig a pit to
Yeah,
make a
yeah,
fireplace or
yeah,
something.
yeah, yeah.
Yeah.
Call
Call
always
before you
call
dig.
before you dig. Yeah, that's yeah. When in doubt, call because case in point, there's a situation that happened. Well, actually, the city where one of the ABB plants is basically there was a backhoe. It wasn't an electrical event, but it was a backhoe doing some preparation work for renovating a road basically and nicked the water line, right? And I'm not talking the water line going into a house. I'm talking about the main water line that went through the city basically. So yes, you definitely have to be calling before you dig for something like that. But to the advantage of going underground, especially if we're talking from we'll say from the hydro pole or from the from the feeder line coming into a household, you got to keep in mind they're not burying these things like at 16 inches under the surface. They're going a little bit deeper, and there's a few a few safety procedures they do put into place because when they do bury these lines, there's a few tricks that they use. There is a yellow tape that's been put above it. So basically the line goes through. There's a gravel bedding or a sand bedding of some sort. So as a backhoe operator is digging through, say you're digging through just black soil, basically, whoops, and then you start seeing gravel starting to come up. That's where you start going easy on the controls. And on top of that gravel, there's usually what's a yellow tape or some kind of indication tape too. So if someone hasn't come by and used any kind of sensing equipment to kind of say, kind of detect what's buried, because you know how it is for all municipalities. There's the plan, then there's the actual setup of what's actually been done. It's always good to have somebody come in and kind of verify where the lines are. So this tape is set above, so when a backhoe is going into there, you'll start pulling up this little yellow tape, basically say, hey, wait a minute. Or even sometimes it's just yellow nylon rope to say, look, if you keep going about 6 inches below this, you're gonna find something you might not want.
Just to wrap up here, I wanted to, when these discussions are happening, where is there any, is there an area, maybe there's not, but if there is, an area of confusion with underground that you run into with trying to communicate, trying to help people understand something? Is there anything that people just generally, maybe they misunderstand about putting an underground cabling system in?
I think the utilities are well versed with these products. They have extremely smart engineers, so very capable staff. So there's very little confusion when it comes to
Mhm.
them installing that equipment or purchasing that equipment. Sometimes they just need information on specifications. You know, can it do 27,000 volts? Can it switch 600, 900 amps type of thing? So they may not know that data, but they'll reach out to manufacturers like ABB to get that information. And they'll also put a specification together saying, you know, we need to switch this much voltage, this much current. It needs to be underground. We need this much fault interrupting fault capacity. We need all, and they would put a specification together telling you the size of that they need and so on. And us as ABB, we would manufacture something to meet that specification so that they can use the product. So from a utility perspective, there isn't really much confusion because
Mhm.
I think they know what they want,
Yeah.
and then they request from the manufacturers to see if we can meet those needs, and if not, what can we do to meet those needs? And
Yeah, and
you
with
know,
that, Jay, I think they continue to train and qualify their people regularly. It's like any other professional industry. Or look at car mechanics, look at doctors. They're just continued training, and they get very good at what they do because they're doing it day in, day out. They just don't. It's just not necessarily a standard electrician that comes in and does medium voltage products overnight. There's nothing that says that he couldn't. It's just that the type of products that we use, they're not that they haven't changed that terribly much over the years, and they always do the same job. It's what they do for a living. It's just that the people that do this do it all day long, and they're used to it. It's a regular operation for them, and that's why the utilities they're as safe as they are, and that they stay on top of these trainings.
yeah, absolutely. No, safety is priority, right?
Yeah. I
And
oh, sorry, go ahead, Jay.
it's not something, Jared, that your average household will run into. I
Right.
mean,
Yeah.
for the most part, a homeowner might see some of the equipment if the utility company happened to be working on that
Mhm.
big green box outside on close to the sidewalk. You know, they may have opened it up to do some connections or some maintenance on it, and then you might see that. But that's the extent of your average homeowner will see it because we're talking about 5,000 volts and up, which your average homeowner or even business will not see. You know, they'll see maximum 600 volts, and maybe higher, unless we're talking about big mining companies and other locations like that where they're supplied high voltages, but or medium voltages.
So
But
at the end of the day, if you want to sum it up in a way a little bit, is that Jay and I are part of the group that tries to keep not just the lights on in your house. We try to keep the lights on in the city is the idea. You're trying to keep the whole grid on, and that's what our job is we're helping keep the whole city on.
yeah, and you know those utilities are advancing, right? They are working with homeowners. I can give you an example. A lot of the utilities are looking to digitize, right? That's a big
Mhm.
big thing nowadays. Using the IEC 61850 protocol, they're trying to collect as much data as they can to be able to make the grid more resilient. They want to understand what's going on with the grid, what's being tied into the grid, home solar panels, big solar sites, 100 megawatt sites that are feeding power onto the grid, and
Electric
so on.
vehicles.
Electric vehicles is another one, right? The demand is increasing. This
Yeah.
is reason why they need data. So I know of a utility company that is actually tied into homes where when the peak demand increases during the day to a
Mm.
point where it could put a lot of stress on the equipment,
Right.
what the utility can do is go into your home thermostat, turn down your air conditioning, turn off your EV charger, for example, your refrigerator, things like that, that to try and bring the load on the equipment down. So they will provide, homeowners that sign up for something like this, they will provide discounts on their electricity bill to be able to reduce the load during peak
Oh,
demand.
there's something you sign up for. I was like, oh man, people are not going to enjoy
No, you have to
it.
sign up.
I
Yeah,
was
because
like,
yeah, if you want taxation without representation to
I
be
just
brought back
picturing,
up, yeah, this will do it. But no,
yeah,
you
I'm just
definitely need to
picturing
sign
someone
up.
trying
Yeah,
to turn up their air conditioner and then they want to go back to
yeah, people love that when other people decide what they're going to have their air
their
conditioning set
temperature.
at. Yeah,
Yeah.
Yeah,
yeah,
for
yeah,
some people it works, right?
Yeah.
Oftentimes, like for me, for example, I have an electric vehicle. I don't charge it during the day. I charge it at night.
Right.
So it's not an issue. But if I were charging it during the day and there was a big peak demand, when they wanted to turn it off, yeah, it might be a problem depending on what I was going to be doing that
yeah.
day. But
And there's feedback loops on that, Jay. From what I've seen, is that
absolutely,
they'll be warning you, hey, listen, we're having a bit of a load issue. We're about to
Right.
stop charging your vehicle, and you're allowed to say no, thanks. I need to leave in 20 minutes, and I'm on my way to downtown Toronto. I need my full load.
absolutely, absolutely. Yeah.
Right.
So with decarbonization, digitization, urbanization, these things are what is on the radar screen of the utility companies today that are looking to produce electricity and provide it to end users efficiently and not have any downtime, so that the homeowner can enjoy, electricity in their home and enjoy life.
It's so interesting. And of course, this is the tail end of the interview, but that's such a and this plays into why we do these long form shows because the educational. Because when you first said that the utility company controls, I was thinking, well, I don't like that. Like I'm not into this. But then if you go, oh no, this isn't. If you're opting into the system, and maybe you get discounts on if you want to be. Then there's that thing where you could say, well, no, I mean, I've got a shift starting in 2 hours. I need to charge my car. So you reject it. All of a sudden it becomes an educational piece because yeah, if I know that the load is high, I would of course I'd go, yeah, that's no problem for me. It comes to that people will be very collaborative if there's
That
an
is true.
educational part for it and they're able to get a say. Then I think people, I mean, there's always going to be people that just say no to everything. There's other people that just say yes to everything. Those are those personality things. But a lot of
Uh,
people in the middle, they sort of, okay, if I know what's happening, I'll work with you on it. I think that's
Yeah,
and
pretty common.
absolutely, what you said there is absolutely true. So if you think about it, gone are the days where the electricity company would make electricity, send it to your house, and if there was a down event, there's a down event.
Mm,
Now there is a lot of feedback, and they're empowering their customers to be part of that electricity grid. So if you think about solar sites, for example, you have independent companies that own those solar sites and they feed back onto the grid.
yeah.
Customers are being able to tell the utility, yes, you can turn my electricity off when I'm not using it. So they empower customers to be part of that resiliency of the grid, if you will, which is great because a lot of customers would want to be involved in that. Some may not,
feel
but it
socially responsible, if you will, environmentally responsible to it too, a little bit. Yeah.
absolutely, absolutely, yeah, it does a big part for the environment as well because when the peak demands are high and you have load concerns and you have to bring on additional generating stations. It could be coal burning, could be many things. So if you don't have to do that, you can reduce the carbon footprint as well, right? So
Yeah.
empowering the customers, the end users, is another thing that the utility companies are doing today,
Well, it's a
which is
very
great.
Yeah.
simple. Yeah, it's just a very simple example of when they say the mileage in your car and you learn how to drive it. You can drive it however you want. You can put it on the sport mode and just floor it and between
Yep.
lights and stopping and starting and who cares? But you'll watch that gas mileage just go or the energy burn out of either battery or whatever. But once you know, now you start to make that decision. I think it's just such a great approach when done right.
Absolutely.
Yeah, and incentivization also drives behavior. So I think that
Yeah.
feedback loop is that incentive, and you start feeling socially responsible, or environmentally responsible for how you're performing your energy consumption. That's for sure.
Yeah, it's an exciting thing. Gentlemen, thank you very much for being on the show. I do appreciate this is our third episode with ABB. Really do appreciate you taking the time to do these shows and everybody at ABB. Natalie and Tim, and just putting in the time to put these together. It's been a lot of fun working with your crew.
Well, thank you very much, Jared, and I look
Mm.
forward to working with you again. And Jay, I'd say it's always a pleasure to chat it up with you. I look forward to doing some future episodes if we've got the time to do some here. I'd certainly like to do another one.
Absolutely.
Absolutely. Yeah. Thank you, everyone. Thank you for your time, and I appreciate it.
And thank you, everybody, for watching. We will put links to ABB. You can find out more information like on their website and everything like that. And even LinkedIn if you want to connect with Jay and Dominic. Thank you, everybody, for watching. Thank you to people that promote the show and share the show and media partners and everything that goes into making this happen. Thank you. We will see you on the next episode of Building Energy.